Hello, seventh graders, and welcome to lesson 3. Today we'll be discussing using properties with rational numbers. What we're going to use a lot today is the distributive property. So I'm going to write that down. The distributive property. I know you learned about this in 6th grade, but let's just review quick what the distributive property is. I'll give you an example. Say we had something like 10 times 2 plus 3. You can rewrite that if you want as, using the distributive property, this means 10 times everything in the parentheses. So 10 times 2 plus 10 times 3. Okay, if you were to do that, 10 times 2 is 20 plus 10 times 3 is 30. That would give you 50. Does this yield the same thing? Well, it has parentheses, so I need to do what's in the parentheses first. 2 plus 3 is 5, and then 5 times 10 is 50 as well. So just remembering that the distributive property says that when you have a number outside smushed next to your parentheses and you multiply it by everything inside, you get the same answer. This is kind of explaining how the distributive property works. And one of the reasons that that's important today is because we want to use that to write equivalent expressions and equations. So we'll try out an example here. And really the use of this is that we can take an expression or an equation and make it a little bit easier for us to solve. That's kind of the reason that we're doing this. So example 1 says an art teacher pays $13.89 for one box of watercolor brushes. She buys 6 boxes in March and 5 boxes in April. Use the distributive property to write equivalent expressions showing 2 ways to calculate the total cost of the watercolor boxes. So you'll see here when I use the distributive property, I used it this way and this way here. So that's kind of what we're going to be doing here for this example. Okay, so write an expression for the total cost using the cost per box and the number of boxes, and then write equivalent expressions. So the cost per box, we know it tells us that it's $13.89. And if we multiply that by our total number of boxes, well, we bought 6 in March, plus we bought 5 in April. That is one way of writing your expression, I should say. Okay. Now that's the same thing. We could write it another way as, well, we're still going to take our cost per box, which was $13.89, and we'll multiply it by how many boxes we got in March, which was 6. And we'll add that to our cost per box again, multiplied by how many boxes we bought in April, which was 5. Okay. This is the second way of writing it. And these two should yield the same answer, but they're just different ways of thinking about it and different ways that you would take to solve this equation. Okay. Now it wants us to simplify each expression to calculate the total cost. All right, let's do that. Let me scroll down here. All right, in the first method, go back to that color I was using. In the first method, we had $13.89 times the 6 that we bought in March and the 5 that we bought in April. Okay, well, since this is in parentheses, I'll add it first. 6 plus 11, or 6 plus 5 gives me 11. And then all I need to do is multiply 13.89 times 11. Let me do that quick. 9831, placeholder, 9831. Add them together. 9, 17, carry my 1. 12, carry my 1. 5 and 1. And then I need to bring my decimal 2 spots over in the end. 1, 2. For a total of $152.79. Let's see if we get the same answer using the other method that we had tried. So we said it's $13.89 times 6 for the March cost and $13.89 times 5 for the April cost. If we multiply each of those, $13.89 times 6 would give you $83.34, and $13.89 times 5 would give you $69.45. Okay, we'll have to add those two together now. Let's do a little addition practice. We'll make sure we line up our decimals when we're adding decimals. 9, 7, bring my decimals straight down. 12, carry the 1, and 15. So we come up with $152.79 for the second method. So both methods result in a total cost of $152.79. We're just showing you with the distributive property that there's multiple ways to do this problem. All right, let's look at the next example. And this example involves fractions. And I know a bunch of you always talk about how I hate fractions. I'm not good at fractions. Well, you should like this, because we're going to write an equivalent equation for this that does not contain fractions. Right? So here's how we're going to do that. To write an equivalent equation that does not contain fractions, you use the least common multiple. Okay, so I'm looking at my fractions here. I'm looking at 4 and 6, because those are my denominators. I'm going to use the least common multiple of those, which would be, let's see, multiples of 4 would be 4, 8, 12, 16. Multiples of 6 would be 6, 12. Ooh, I found it. The least common multiple of those is 12. So what I need to do is I need to multiply both sides of my equation by 12. And essentially what that'll do is it'll get rid of my fractions. Okay, 12 times all of this on the left-hand side, and 12 times whatever on my right-hand side. And let me show you how that would work. It'd be 12 over 1 times 3/4 times 3/4. All right, what happens here? Well, you could simplify first. Dividing each by 4 would yield 1 and 3. And then multiplying it across, 3 times 3 would be 9 over 1, which is 9. So you could see here that all we did is we made 3/4 x. When we multiplied that by 12, we turned it into 9x, which is super nice. Now I got rid of my fraction. All right, again here showing that they simplified same as I did right up here. And that would turn into a 1, right? And you could do the same over here when we multiply by 12. 12 over 1 times 5, 6. Simplify first, divide each by 6 would yield 1 and 2. 2 and 1, we'll go here. And then on top I have 2 times 5, which would give me 10 over 1, which is just 10. All right, so let's see what I'm working with here. 3 times 3, x was 9x. I got that. Plus, okay, don't forget that you also need to take 12 times 7. 12 times 7 will give you 84. Equals, we said 2 times 5 was 10. So we took 12 and we multiplied it by 5, 6. Now look at my equation. I've got 9x plus 84 equals 10. This is a lot easier than this top equation. Now I don't have to worry about fractions. I can just solve this using whole numbers. Okay, what's being done to my variable? Well, two things. It's being multiplied by 9, And it's also being added by 84. I need to subtract 84 on both sides first, because when you undo, you have to do PEMDAS in reverse. So that leaves me with 9x equals 10 minus 84. I couldn't do in elementary school, so I know it's got to be a negative. And 84 minus 10 is 74. That's where they get this right here. And lastly, I'll divide by 9 on both sides. And x equals 9 is negative divided by positive is a negative. So you could just say negative 74 over 9. Or if you wanted to rewrite that, 9 goes into 74 8 whole times, which would be 72. There'd be 2 ninths left over. And don't forget that a negative divided by a positive is a negative. All right, there you have it. A little bit easier to work with equations that do not have fractions. Now, could you do that? Yeah, you could solve it using fractions, but it might be a little bit messier. All right, let's look at our last example, and then you can have some time to try that on your own. It says the soccer team uses a 36.75 liter container to take water to games, right? It's pretty normal. The team manager fills 0.75 liter bottles from this. So 3/4 of a liter bottles, but he's already used 22.5 liters. How many more 3/4 liter bottles can he fill before he runs out of water? Write and solve an equation. Write and solve an equivalent equation without decimals. Okay. So first we need to write our equation. I know that my total is this 36.75, so I'm going to write that at the end. Equals 36.75. That's my total. And how can I figure out now what to put on the left-hand side? Well, I know that the team manager fills bottles that are 0.75 liters, and each bottle is that much. So I'm going to say 0.75 times each bottle, so x times x, plus I've already used 22.5. Okay, when each bottle plus the amount I've already used equals, in the end, I have a total of 36.75. Okay, so now it wants us to write an equation without decimals. So I'm going to have to multiply this. In the last equation, I multiplied it by the least common multiple. Here, where I have decimals instead of fractions, I'll just multiply. Use the equation had decimals to the, and that would be, I have tenths here, and I have hundredths here, and that's the biggest. The maximum amount of place values. So that's what I'll use with hundredths. I'll multiply both sides by 100. And when you multiply by 100, that's the same actually as moving your decimal 2 spots to the right. So essentially, when I do that, I just need to move each one of these numbers, decimals, 2 spots to the right. So 100 times 0.75, moving it 2 to the right, would give me 75x plus 100 times 22.5. One spot would be 225. Another spot I need to add a 0. So 2,250 equals 100 times 36.75. I'll move it 2 spots, 3,675. Now my equation doesn't have any decimals. It's a lot easier to work with. So like before, I need to move my 2,250 to the other side. So let me just show you over here. 75x plus 2250 equals 3675. left and right. I need to isolate my x. So first, I'll undo adding. Okay, that'll cancel, and I'll be left with 75x equals, do a little subtraction here, 1,425. 1,425. And in my last step, divide by 75 on both sides. And 75 goes into 1,425. If you want to use a calculator here, that's fine by me. 19 times. So the team manager can fill 19 more 3/4 liter bottles. All right, that does it for the examples today. If you would, please pause the video now. Try the 3 check it out problems on your own, and then come back to see if you got them right. All right, for number 1, Eli and Max each pay $3.75 for lunch using their lunch cards. Eli buys 8 lunches and Max buys 5. How much more does Eli pay than Max? Okay, so if I were to write an equation for this, I would say, well, each lunch is $3.75. And what I'm going to do is I'm going to take the difference between these two. Eli buys 8, and I'm going to subtract how many Max buys, because that'll tell me the difference between the two of them. Difference, remember, means subtract. Remember, if I were to write an equivalent expression, that means the same thing as Eli's would be 375 times 8. The difference between the two, if I were to subtract, Max is 375 times, well, he only buys 5 lunches. Okay, do a little math there, excuse me. 375 times, well, 8 minus 5 is 3. And if you multiply 375 times 3, you'll come up with $11.25. Now you could do the same over here, just to double check. That 375 times 8 would give you $30 that Eli pays, versus Max, the 375 times the 5 lunches is $18.75 Max paid. So the difference of those two, 30 minus $18.75, would give you $11.25, the same as we got over here. Okay, Eli pays $11.25 more. Obviously, he had 3 more lunches. Okay, now you could do that a different way as well. You could just look at the beginning and say, okay, Eli buys 8 more than Max does. Or excuse me, Eli buys 8, Max buys 5, he buys 3 more. So you could just take 3 times the 375 per each lunch, and you would get the same answer. Multiple ways to do that. For the next one, you need to use we're trying to write an equivalent equation that does not contain fractions. So I'm going to look at the least common multiple between 7 and 3, which would be, 21, I believe. So I would multiply each side by 21. Multiply each side by 21. So 2/7 times 21. 21 over 1. Simplify first would be 1 and 3. Multiplying across, 3 times 2 would be 6. So this will be 6x plus, I need to take 21 times 6 as well. That would give me 126 equals, okay, I need to also take 21 times 1/3. Simplifying first by 3 would give me 7. Okay, Here's my equivalent equation. Now to solve, I'd have to subtract 126 on both sides. That will leave me with 6x equals 7 minus 126 would be negative 119. And then divide each side by 6. Should come up with x equals negative 1956. Or if you wrote that in a decimal form, negative 19.83 repeating. Okay. And lastly, the writing an equation one, Celia spent $11.80 on supplies for the pancake breakfast. She bought cartons of orange juice for $2.35 each, and a large box of pancake mix for $4.75. How many cartons of orange juice did she buy? Write and solve an equivalent equation without decimals. Okay, so I know that, again, each is a hint here. So $2.35 times each large box, so times X. Plus, she also paid $4.75 for pancake mix, should equal our total of $11.80. That's your original equation that you should come up with. And if you multiply each side by 100 to get rid of your decimals, you'd come up with 235x equals plus 475 equals 1,180. And then you'd subtract 475 on both sides and come up with 235x equals, again, your calculator is fine here, 1180 minus 475 would give you 705, and divide each side by 235. Divide by 235. You'd come up with x is equal to 3. And remember, that's cartons of orange juice. All right. There you have it for lesson number 3. Let me know if you have questions. I will see you next time.